Hello everyone. So for this video, we're going to start talking about the observer pattern. So what does the observer pattern solve? So suppose you need to inform a lot of objects about changes to some interesting data. So let's say you have some interesting data. Let's call this interesting data right here your subject. Let me rename that one. This interesting data is kind of a long name. So I'm going to call this the subject. Oops. You may rename all instances of interesting data to subject as such. And your subject can be any kind of class, any kind of object. So for this one, let's just keep our subject as some string to make it simple. And the reason why this is interesting data because some client class is interested in this subject. This client class wants to know whether or not the value of this one has changed. Let's say this is another part of your system, this client class right here called client for now. And this client needs to have an updated copy of your data. And it always wants to know if something has changed, or maybe it doesn't need to update its value. Maybe it just needs to know if something has changed around it. So this can have a lot of applications. For example, do you have a system that um, is watching for measurements of a specific value. Let's say you have some kind of, you're working on like a sensor, for example, and you need to check if the value of a sensor changes. And depending on the new value of the sensor readings, some other part of your system will react to that. Like let's say you have a light sensor. So I'm thinking of a a real world example of this one. And this light sensor right here has some attribute called light level. And you have, let's say, a light bulb class, light bulb instance right here. And this light bulbs wants to be updated about the value of this light level from light sensor. Because if this light level becomes too low, then the light bulb will turn on, for example. So that's a real world example of having some interesting subject, having some interesting data that other parts of your system might be interested in. So for the example I have right here, I just kept it simple just to make the demo easier. In this one, I have a string for my subject and I have this client class right here. So how would the client want to be updated if there are changes? So a naive way of doing this, a way of doing this without a pattern, is to always check, always have a copy of this value right here, and then check, for example, if this has changed. So if this has changed, then you'll do something. You'll have a reaction whether or not it has changed. So in this example right here, we have this function has changed, and it will basically just compare interesting data right here passed as a parameter with its own internal copy of the data. And depending on its own copy, depending on if there are changes or not, then it will react. So for example, here, if client has detected changes to subject, then it will just print some statement, client that announce changes. So let's see this example in action right here. Let me go to the um, correct directory first, and let me compile and run this one. Hmm. Am I in the correct? Let me check if I created this one at the correct. Oh, I'm not the um correct directory yet. I think I need to go to dot slash scratch. There you go. So let's compile and run. Oh, still not here. Go ahead and save it. Oh, sorry. I accidentally put a dash right there. So the dash was supposed to be there because but I forgot the D part. Destination. Hmm, something's up. For some reason, it does not is not able to detect my main function when it is definitely there. Let me step. Oh, I see it now. Sorry for the delay. The mistake was I used the wrong command. It should be Kotlin C for Kotlin compile. And there you go. So if you trace what's happening right here, originally the value of the subject is some string. And then we have this client created this client right here to watch for this subject. And then during the creation, it's going to update the value of some string of this data copy right here. And then we check that we try changing the value of the subject, and then we check if this value has changed, and then because it has been changed, since this is a new value right here, then it will just call announce changes, which will just throw a print statement. And also we also need to update the value of data copy right here. Actually, let me unify this one. Spending a lot of time for the non-pattern version. Let me update this first. Okay, so I just added a change right here so that it doesn't only have to return true or false. It also updates the copy of the data copy if it does indeed detect that the data copy that it has is out of sync with the subject right here. Let me write the correct type signature for this function. Oops, my bad, my bad. There you go. So that's basically how you would do this. And you might see right now what are the perils of this solution right here. You always have to check this has changed. You always have to call this function has changed right here because you need to be always ready if there are changes. And right now, it's obvious that our subject has changed right here because we know that from one line over, we are reassigning a subject right here. But what if it's in another part of your system? What if you can't always check for this one? What if the changes to your subject might be unexpected? It's not something that you can always predict. Like the example I had with the light sensor, you can't always predict that the light levels would be low enough for the client class to update, for the light bulb to turn on, for example. And that's the reason why this is not a good solution, because you need to always perform this hash change check as often as you need to. So you might need to call this every second, for example, if you anticipate that changes to this subject right here is that often, you might have to update this every 5 seconds, etc., depending on how often you think the subject will change. And that is very heavy for the system. The constant checks, the constant updating that might not even be necessary because your subject actually hasn't changed, but you still have to check. And because of that, you end up with a very bad system. And this example, this has a name. This is a polling for changes. Polling, basically asking the subject if there are changes to the data. That's what it means when you say polling for changes. Forcing your objects to poll for changes regularly all the time will be inefficient if your interesting data has not changed, because you keep on doing it unnecessarily. But since you always have to be ready, as whenever there are changes, you still need to do it as often as possible. So what is the solution for this one? We just have to change the responsibility of sharing information about the changes to the subject. Instead of making it the responsibility of the client class to ask, to poll, or to check if your subject has changed. Instead of doing that, what you need to do instead is you need to create a notifier class that will be responsible for updating all of the interested objects whenever there are changes to your subject, and only when there are some changes to your subject. This class will be responsible for notifying interested clients about changes on the subject. To do this, you need to encapsulate the interesting data, and yes, we're going to call it subject, into what is known as a publisher class. An instance of this class will be responsible for notifying the observers for any changes in your subject. And whenever there are changes to the subject, publisher instance calls a special method called notify observers so that all interested observers will be informed of the changes. So how would this look like in a class diagram? So you have a publisher right here, and the publisher is where you would put your subject, and you would put your subject right here as an attribute. So for example, if your subject is a string, then your publisher will have the subject as an attribute. And it also keeps a list of subscribers, and subscribers are what interested observers that want to know if the subject has changed. And the special functions that you need to add for your publisher would be the following. You need a notify observers, and this is basically going through the list of observers in your publisher, in your subscribers, the list of observers. And one by one, it will call update. It will basically tell them one by one, oh, subject has now changed. React accordingly. And then you also need the subscribe and unsubscribe methods right here. And this is how you would add or remove subscribers in this list of observers right here. And then finally, you have the update subject right here. And this is the only way for you to change or update the private attribute subject. And I'll explain later why this has to be private and all changes have to be done through update subject. And the other important classes, you need an interface observer, and it will only contain one abstract method, and that abstract method is update subject. And this is basically the method that specifies how the observer reacts to changes to the subject. Does it print a statement in the same way that this client right here? Does it not print anything? Does it just update its own copy, etc.? It depends on the observer realization. And the observer realizations will, of course, realize from this observer interface right here. So let's try to write this in code as such. Okay, so again, the first thing that we need would be the publisher object. And this publisher, for example, will accept a string, and this is where we would store, or where we would get the value of the subject that will be stored as an attribute of publisher. So val, oh, it has to be a var, sorry, since we expect this subject attribute to change. And for our example, this is just a string. And contents of this one, it needs a list. I'm gonna need it to be a mutable list. This list of observers known as subscribers. Oh yeah, I think I made a mistake right here. This shouldn't be a list of observers. This should be a mutable list of observers, since we expect the list of subscribers to increase or decrease. Let me check if that's correct. Yeah, I made a mistake with the class diagram right there. So right now you can keep this empty during instantiation, because whenever you instantiate a new publisher, you can instantiate the subscribers to be empty first. It doesn't have any subscribers when you construct it. So you need to specify that this is a mutable list of observers, and that cues us into creating the, oh, after na lang, that will create the observers. And the functions that the publisher needs to have, it needs to have the notify observers function. And what it does, through a for loop, it will go through the entire list of subscribers for every sub in subscribers. It's going to call sub dot update subject. This is basically the method where we notify all of the subscribers that you can find right here, all of the observers in this list. We tell them one by one that, oh, subject has now been changed. So just to get rid of these errors right here, I'm going to create the observer interface. And the observer interface will only contain one abstract method right here called update subject. And this is where we define how the observer reacts to the changes to the subject. Sorry, I wrote the wrong keyword. This should be fun. It's a function. And when do we call notify observers? We call notify observers whenever there are changes to the subject. And before I forget, another important thing is to keep this subject right here private. We want to keep this private so that there is only one way to change the value of this subject. The only way for you to change this is through calling the method update subject as well. Sorry, I need to rename this, I think. Ah, no, that's correct. Actually, let me do that. Let me rename this one, since they have similar names. It can get confusing. I'm gonna call this one just update. It's updating itself, or yeah, it is being updated on the changes to the subject. And this one does accept a subject instance as one of its parameters. I missed that. So in our case, since our subject is just a string, so this should be a string as well. Oops, sorry. There you go. Mm, okay. So our update subject method for publisher, this is where you would change the value of your subject. You just need to pass a new subject value right here. This is also known as a setter because it sets a new value for a specific attribute in your class. And the class in this case is your publisher. Oops, sorry. This has to be a string. And here we're just going to overwrite the value of the subject attribute into the new subject that's being passed as a parameter right here. And again, every time we're going to update the subject, we need to notify the observers that the subject has been changed. And this is basically the updating in action. And this is also the reason why we need to add the multiplier private for the subject right here. Because since we kept this private right here, this subject attribute can only be accessible inside this publisher class definition. Meaning, outside the definition of publisher, we can't call or we can't overwrite the value of subject this way, like that. Since subject is private, the only way for you to change the value of subject is through something like this, by calling the update subject method of the publisher, so that you are always sure that whenever the subject changes, you also notify the observers at the same time as well. And other methods that you need a subscribe method. This is basically adding a new subscriber into your list of subscribers. Automatically imported some stuff that I don't need. The autocorrect. So this new subscriber is of type observer. And all we have to do right here is to call subscribers.add new subscriber to append this new subscriber into the list of subscribers. And unsubscribe is the opposite of this one. It's gonna accept an X subscriber that is going to be removed from the list of subscribers. It's going to be taken out of the list. Basically, clicking the unsubscribe button in the email. I don't want to be updated with these promotions, something like that. So for this one, we're just going to call subscribers dot remove X subscriber. We fix the spelling. There you go. And these are the 4 methods that you need for publisher. The next thing that we need right now would be your observer realizations. So that would be your clients, for example. I'm not gonna call it client for this one. I'm gonna call it real observer one just to make the name as descriptive as possible as to what this is. And let's say real observer one. Let me just check my Codigo for a bit. Keeps a copy of the subject in its as an attribute. So this class instance right here needs its own instance of the subject as well. So we need to override the abstract function update. Right there. Oh, I need to make sure to establish the abstraction realization relationship. And again, let's say for this observer realization right here, it needs to update its own copy of the subject. So it has an instance of subject copy right here, which starts as empty. But when it is updated, it's going to be updated based on the subject that you pass right here. So we update subject copy becomes subject right there. And that's the behavior of real observer one. And let's say another observer realization right here called real observer two will not update its own copy. It's just going to print a statement every time it detects that the subject has changed. So here, just have to directly override our update method right here. And in here, we're just going to print subject has been changed to $new subject. Okay. So let me just copy the main function that I have in my in my Codigo right here. So for this one, the publisher instance right here accepts a new subject. So let's say we have a subject right here, and this subject is some string. You can just write it directly here. There you go. And whenever you change the subject right here, again, you have to call update subject. Let's demo this one first and see what happens. So I'll recompile and rerun it right here. And let's trace the code. Oh, this is not the right thing I'm running. This is my Codigo I'm running. Have to just rerun the command a while ago. Recompile and rerun scratch.kt right here. And oh, there's an error. There's a warning. Mm, let me just check out this warning right here. Line number 32. Ah, okay. it's complaining that the name of this parameter right here doesn't match the name of the parameter in the interface that it realizes from. So it's not really, you don't really have to do it, but it might cause confusion. So it's suggesting for us to rename this so that it matches. It also might cause problems in calling this function with named arguments. So let's save it, rerun and recompile and rerun. Okay, so let's see what's going on right here. We create a new instance of publisher and we add this subject right here with the value sum string and create two instances of observers right here, observer one and observer two, and their types are real observer one and real observer two respectively. And these observer realizations can then subscribe to our publisher instance using the subscribe function. So publisher.subscribe observer one and observer two. And whenever you update the subject, updated subject right here, you're going to print observer one dot subject copy as well to see if the copy of observer one is being updated as well. So the two lines of print that you see right here is from the update subject. It prints subject has been changed to updated subject, and this is observer number two reporting that there are changes to the subject. So whenever observer 2 detects changes to the subject, it just prints this line right here, which matches to the first print that you see here. And then after that, we're also going to print the value of the subject copy, which is now the updated subject. For example, if we change it again right here, if we add another publisher dot update subject again, and let's see, subject has been changed to newer subject. So we can see right here that by calling this one, all of the observers will also react. And let's see if unsubscribing will work. So if I, for example, unsubscribe observer one from the list of subscribers, and let's say I do that before updating the subject into this string newer subject, for updating it here. Sorry, I forgot to print as well the value of observer one dot subject copy. Okay, let's see it here. So before we updated the subject, we unsubscribe observer one from the list of subscribers. And because of that, whenever we call update subject again, observer one is no longer notified to the changes to your subject. And since it's not notified anymore, when we check its own copy of the subject, its own copy is not up to date. This is its copy, but this should be the correct value, since again, it has now unsubscribed from the publisher itself. And one more thing I didn't mention right here. This one is not required, but it might be useful that whenever you subscribe a new subscriber, you also call new subscriber.update. Since this subscriber is a new subscriber, you might want to give it an up-to-date value of the subject. Since it hasn't been updated yet, you assume that it hasn't been updated yet because it is just a newly added subscriber. So you might want to call new subscriber that update so that it gets up to date with the value of the subject. And yes, that's basically the observer pattern. So the example that you're going to implement in the lab exercise, you're creating a push notification system that works for multiple platforms. You want to distribute information about the current weather and news headlines. This system will be potentially used on many platforms, so you have to think about the maintainability issues for adding new platforms. To implement this, you will have to apply the observer pattern, and your subject for this case would be weather data and headline data, which are already pre-written for you, and these are their own classes as well. And these subjects should be encapsulated into a single publisher class, and this publisher class will be called your push notifier. Any platform that is interested in changes to the subject, which refers to the weather and the headline data, should realize a subscriber abstraction. This is your observer. And this contains the abstract method update, which updates the headline and the weather, which are again the subjects as well. Uh, let's see first the current code that you would have while implementing this. I think this should be exercise 16. Oh no, it's 15, I believe. Yes, there you go. Okay. So the current code that's already written for you have the headline, which has a two-string function so that you can print it directly using print or println, or you can just convert it to string using dollar. It has its own string representation. Weather as well has that. Headline has the following values: headline, the headline itself, details of the headline, and source of the headline. Weather data has temperature, humidity, and outlook. These are all floats, and then string. And this is what the push notifier looks right now. You have to populate this with what the push notifier should look like. And the realizations for your subscriber would be email subscriber and file logger right here. And your email subscriber, you don't actually have to implement emailing the user when you update the weather and the headline. You're just going to give it a print statement. I think I mentioned it right here. Oh, it's not here, so I should have to add that. So the email subscriber right here. Yes, you don't have to print, you don't have to email anything, but if you want to, you can do that. You'll just have to do, I don't know how Kotlin does emails. In Python, I remember there's a way for you to create an email server. But nevertheless, again, you don't need to do that. You just have to simulate emailing an email address whenever this email subscriber is updated of the new weather and headline. And also you have a file logger right here. And this file logger contains an instance of a file class, which points to a file in the computer. And whenever there are changes to the subject, you need to append a new line to this file right here. And that's basically it. So here are before we talk about the steps, so why is this pattern elegant? You can easily add new observer realization seamlessly every time there are new objects that are interested in the subject. So for example, if there are new platforms that want to be updated of the headline and weather subjects, you can just create new realizations for observers. And an observer can be subscribed or unsubscribed during runtime. You can easily detach or attach subscribers using the subscribe or unsubscribe methods of your publisher. And here are the steps. And that's basically it for this pattern. Thank you, everyone.